perform substitution or permutation. But substitution and permutation are not simple over here. What we have considered or what we have to see over here, there are multiple things which are to be considered. So which multiple things are to be considered? So that is even important from here, that what exactly you people have to do. So for that we have seen that feature cipher structure is there. So plain text is given, number of rounds are there. After that again you are getting the ciphertext. In case of decryption, the ciphertext is given, and then again number of rounds are applied, but it in reverse. So 16th number round, then 15th, then 14th, likewise the first round, and then you are getting the plain text back from the ciphertext. So this is nothing but your Feastal cipher structure, which you can consider as for modern, all the modern cipher, AES, DES, triple DES, and many more ciphers are there. For all those ciphers, what we have concentrated on is this new type of structure, that it is Feastal cipher structure. Something has to be repeated for some number of times. Now the actual cipher which was discovered, so that was just an idea, that what has to be discovered, when has to be discovered. So the idea is implemented in 1977 for the first time, and what was introduced was in 1977 DES was developed. So DES is nothing but data encryption standard, which is using the Feastal cipher structure for doing encryption and decryption, and is considered as modern cipher and widely used by people in community. So it was considered as widely used cipher. So as I told you that not a beat at a time or not a byte at a time. So in case of stream cipher, we are using a single beat at a time to do decryption and encryption. In case of stream cipher, either we are using a beat or a byte. But in case of block cipher, we are taking multiple beats or multiple bytes at a time. So in case of this, in case of encryption for using DES, what we are having is 64-bit data. So 64-bit data is taken at a time. So here you can see over here that input to DES is 64-bit data. This is nothing but your plain text. And the key length, again the key length is playing a crucial role, because in previous lecture we have seen that which are the principles for designing modern block cipher. So in modern block cipher, the most important part is what should be the size of plain text, what should be the size of the key, and how the rounds are implemented on all this blocks, or how many rounds are to be used. So these were some of the questions, some few of the questions, because in case of providing security, there should not be the gap of losing the computation power, or computation should not slow down. So that was the issue, general issue with the developer of the ciphers. So in developing the cipher, the first cipher which was developed successfully and widely used, and it was widely used, widespread use of this cipher was that which takes 64-bit plain text and 56-bit key. Now see this, that the key is given as 64-bit only, because had you ever seen that 56-bit can be given as a key? 64-bit key is given, but from that only 56 core beats are used in case of key. So for that reason, it is considered as DES with plain text with 64-bit and key bit 56 beats. So 56-bit key and 64-bit data plain text is used in case of DES. So that was widely used and has been considered controversy over its security. So whether it is secure enough, because all the classical ciphers are having this or that flaws. So all these flaws are to be overcome. So DES was one of the solution, or one of the criteria through which you can provide. So exactly how DES was developed, because if you know the history of DES, you will see that a lot of efforts are done by the developers for developing a stable cipher, and the first stable cipher was DES cipher. So whether you people are getting what I'm telling you, because okay, fine. So here the thing was this, that DES was the first cipher which was invented. So IBM has developed before DS. IBM has developed one of the cipher which is Lucifer cipher. So DS is considered as the advanced version of the Lucifer cipher. So that was developed, but with what condition? So the plain text bit was used 64-bit, and the key which was used is 128-bit. So what is the difference between Lucifer and DS? So Lucifer was one of the cipher which is again using a Feastal structure, but number of bits in the plain text which were used are 64 bits, and number of key bits which were used are 128 bits. So again, it was, you can say that, given to the community to prove whether it is secure enough or not. So again, it was redeveloped because the speed of that cipher, Lucifer cipher, was considered as a slow one. Or it was, when you are doing encryption and decryption, if it is taking so much time, then the security at the cost of computation that can't be considered. So because of that, it was redeveloped and it was commercialized. It was commercialized by NSA, and then again some new standards were developed, and IBM submitted the revised Lucifer, which was initially accepted as DES. So who has developed DES? Again, IBM people has revised the Lucifer cipher, which is having 64-bit key and 64-bit plain text and 128-bit key into DES. So DES is advanced version of Lucifer cipher developed by IBM. So there are some controversy that the standards, the DA standard in public, when it is developed at that time, it is considered as whether it is secure enough. So now the choice is, the key length is reduced than that of Lucifer, because Lucifer is having 128-bit key and that of DES is having 56-bit key. So if lesser key length is there, then then too you can say that it is secure enough. Now it was specified that if you are decreasing the key length, then too the cipher security remains the same. So because of that, DES was universally accepted, and that was considered as public analysis was done, and the fact was that DES can be accepted for legal application, for all the legal applications. DES was used in 1977. It was developed. Now this is the overview of the DES algorithm, that exactly how DES is working. So data encryption standard. So this is an encryption method, that exactly how DES is working. As I told you that it is a modern cipher which is using feistal cipher structure. And apart from that, what exactly it is, that you are having a block of data. So it is not a one byte or a one bit, but a block of data is taken. So here you can see over here that in a single byte of DS, you are having 64-bit plain text. So the plain text which is given, the data which is given at the time is 64-bit, and the ciphertext what we are getting is again the ciphertext. What we are getting is again 64-bit ciphertext. So 64-bit plain text is converted into 64-bit ciphertext. So that was the criteria which is used in DES algorithm. That in DES algorithm, what we are having is 64-bit plain text, and this 64-bit plain text is 64-bit plain text. What we are getting is the corresponding ciphertext. 64-bit ciphertext. Okay, now considered over here that what exactly is that. So here in case of DS, number of rounds are considered as 16. So 16 rounds are considered for DS algorithm with 64-bit plain text. Now apart from that, what is the length of the key? Now initially the key which is used is 64-bit, but from that only 56-bit. 56-bit are used as the initial keys within DES. So 8 bits are totally eliminated from the original key of 64-bit. So see this thing in mindset, many times the question is asked that what is the key length in DES? So key length in DES is 56-bit only. So although the input to DES is 64-bit key, but there is one matrix, or you can say permutation matrix, which is eliminating 8 bits from the 64-bit, and the core what you are getting is 56-bit. So from 64-bit, 8 bits are discarded, and 56-bit key is used. Only this 56 bits are used in case of key generation. So all these rounds, round number 1, 2, 3 till round number 16, what we are providing is key. So key 1, key 2, key 3. So original key is divided into 16 sub-key. So this is considered as sub-key matrix. So this is considered as sub-key matrix. So from 56-bit key, some operations are performed, and the operations which are performed are left circular shift. So depending on number of rounds, round number 1, round number 2, round number 3, you are having different number of shifting. So shifting by 1 beat, shifting by 2 beats. So how many beats shifting is needed for left circular shift? It depends on which round you are concentrating on. So all the rounds are having different number of circular shift. After that, the second thing which is included is permutation choice 2. So permutation choice 2 is converting 56-bit into 48-bit. So again, permutation choice 1 is discarding 8 bits, from the original plain text, and then you are getting 56 bit, and then from this 56 bit again permutation choice 2, it is discarding 8 bits, and what we are getting is 48 bit. Now this 48 bits are given to all the rounds. So what is input to for this rounds, round 1, round 2, round 3? So round 1, all these rounds are getting 64 beats, are getting 64 beat plain text beats, but they are getting 48 key beats. From all the sub key rounds, what you are getting is 48 key beats. So this is sub key. So sub keys are providing you something, and these are given to the rounds. All these rounds are getting something or the other, but this is input. Two things are input to all the rounds, because now the next thing what we are going to do. So initial permutation. What is the meaning of permutation? Permutation signifies that internally all these plain text beats are internally jumped. Jump means they are internally changing the positions. So positions of this plain text beat are internally changed, and it is considered as initial permutation. See properly the names of all this, because this is the most important thing from DS point of view. You should know the exact DS algorithm, how it works. So 64 beat initial permutation are jumbling all the 64 beats, and they are reshuffled, or they are re-changed, or they are replaced. After that, what you are having is, as you know, transposition. They are transposed. The position of all these beats are changed, and 64 beats is the output from the initial permutation, which is given to round one. Round one, again, the output of round one is given to round two. Likewise, how many rounds are there in DS? There are 16 rounds in DS. After that, here we will concentrate on single round of DS, that exactly how the single round of DS is working. So see this diagram properly, that what is there in single round of DS. So before that, I want to show you one of the PPTs which are from Barrows Forozen. As I told you that some of the PPTs are very nicely given in William Stalling, or most of the PPTs are taken from William Stalling book only. But in Barrows Forozen, this DS and with example DS is given very nicely. So as I told you that DS is nothing but data encryption standard. So the round one single round of DES can be easily explained using this, and that is nothing but using Barrows Forozen in book, which is security and network security, cryptography and network security book by Barrows Forozen. It is given nicely that data encryption standard. So what is DS? It is a symmetric key block cipher published by National Institute of Standard and Technology, NIST. So there should be a standard that there should be a standard which is universally used by all the internetworking media. So for that they are establishing, or they have developed a algorithm, and that was DES. So DES, as I told you that NIST has published the request for a universally accepted cipher, a symmetric cipher, which should be a block cipher, and it is a modification of the Lucifer cipher by IBM. So DS is nothing but modern, or you can say modified version of Lucifer cipher, and then it was registered in 1975. So DS was registered in 1975. It was drafted in 1975, but the standard version, or it is INST has published it universally in 1977, which can be universally used. So you can see over here that encryption and decryption in DES, how it is working. So 64-bit plain text, DES algorithm, it is converting 64-bit into 64-bit ciphertext. So that is nothing but encryption standard, the encryption process of DES. And what it takes. So as I told you that 64-bit key are given, but from that 8 bits are totally discarded, and the core 56 bit are used as a key. So the key length of DS algorithm is 56 bit only. So 56-bit key is given as input to DS algorithm, and what it generates is 64 bits. So this is nothing but a general, you can say, a black box of DS, how it look like. So given 64 bits, generate 64 bit ciphertext, takes input 56 bit. And in case of decryption, again the reverse is taken, 64 bit ciphertext DS reverse. Now see this, that whatever you are doing from round 1 to round 16, in case of decryption, it is totally reverse of that. You are taking from round 16, 15, 14 likewise, and what you are getting back is the plain text, 64-bit plain text. So this is nothing but decryption process of DES. Now we will go within that box, that what exactly is there in DES cipher. So in case of DS ciphers, many things are to be considered. So as you can see that the process is made of two permutation P boxes. We are having P boxes, P signifies permutation boxes, S signifies substitution boxes. So P signifies substitution, P signifies permutation boxes and S signifies substitution boxes. So as I told you that it is adapting SP network or SP, S and P. Both the things are done multiple time at multiple stage. So because of that, you are having two initial permutation and final permutation P boxes. So two P boxes are there, which is initial and final permutation, and then you are having 16 feastal round. As we have seen that what is feastal cipher? So it is having some round off function, it is having XOR function. So the same thing is adapted in case of DES. You are having 16 feastal rounds, and these are nothing but round off function. And then this initial permutation, so these are nothing but how we will initially concentrate on DES. So this is exactly what is within DES. The 64-bit plain text, initial thing which is performed on 64-bit plain text is initial permutation. After that, you are having 16 round 1, 2, 3, likewise 16, and then you are having final permutation. So final permutation is nothing but whatever we have done in case of initial permutation, exactly reverse of initial permutation is nothing but final permutation. Now all these rounds are taking some input from the key. Now this nothing but key generation or key generator, round key generator. So round key generator is taking 56-bit key, and from this 56-bit key, what we are getting is key 1, K1, K2, K16. So these are nothing but 48 beats. So 48 beats are taken as input to all these rounds. So K1 is nothing but the round key generator is giving the first 48 beats, which is given to round 1, and then K2 is given to round 2. Likewise, how these keys are generated, so we will see in round key generation algorithm that exactly how it is generated. But this is just the overview that what is there within DES. So DES takes 64-bit, total number of rounds are 64-bit, total number of rounds are 16. What it takes is 56-bit input. From this 56-bit input, there is a generator which is round key generator which is converting it into 48 bits, but you are having this type of 48 bits which are generated from round key generator 16 times, because 16 rounds are there and all these rounds are taking sub keys. Now these are nothing but sub key from the original 56-bit key. It is taking 48 bit 48 bit 48 bit keys, because here if you remember we have discussed two things, which is diffusion and confusion. So confusion was a property which is very important, that there should not be one-to-one relationship between key and ciphertext. So when you are generating the ciphertext at that time, the relationship between the key and that of ciphertext should be as complex as possible. So that is possible using this round key generator matrix. So round key generator matrix are deploying multiple ciphertext key beats within all these rounds. So all these rounds are taking multiple ciphertext beat keys. So because of that, the confusion property is possible. So confusion property is possible because key to ciphertext analysis should be as hard as possible. So here this is the just overview that what exactly you are doing. Initial permutation, then key generation, and then 58-bit key, 48. So this just concentrate currently on what are this 58-bit, 48-bit, initial permutation, 64-bit. Now we will see exactly how the things are applicable over here. So here permutation means what? Permutation means what? Changing the position. So what is there in initial permutation and final permutation? So initial permutation, you can see over here that beat number 1 is taken at position number 40. Beat number 2 is placed as position number 8. So in initial permutation, all these beats are originally, these are my plain text. These are my plain text. So plain text beats are internally jumbled. So you can see over here that what is this 1, 2, 3, 4. But how you are getting the first beat? So first bit is nothing but 58th beat. So 58th beat is taken as first beat. Likewise, second beat, third beat, eighth beat. So second beat is considered as the eighth beat of the output. So the output of initial permutation is nothing but 1, 2, 3, 4, 5. Now this is nothing but from the initial permutation from where it is coming. So it is considered as wiring, internally wiring of all the bit datas, and you are changing the position of internally everything. Now the same thing is applicable in case of final permutation. As I told you that what is final permutation? So final permutation is reverse of initial permutation. So from the initial permutation, in case of final permutation, so what has to be done? So 48th beat has to be kept as first. So 40th beat is kept as 1. You can see over here that 40th beat is kept as 1 in case of final permutation. So in case of final permutation, whatever we have jumbled initially, after all the rounds, 16 rounds are performed, again it is repositioning to the original beat position. So 40th beat is again taken at the first. Likewise, 25th beat is again taken as 64 beat. You can see over here 64 beat was taken as 25th. Now here 25th beat is again taken as 64. So whatever initial permutation, this is nothing but reverse of initial permutation in case of final permutation. So this was considered. You can see over here that this is initial permutation. Initial permutation means what? How you are getting the first bit of the output of initial permutation. So first bit is nothing but 58th beat. Second bit is nothing but 50th beat. Third bit is nothing but 42 beat. So these are nothing but beat position. So these are nothing but beat position of your initial permutation. Likewise, these are the beat positions of your final permutation. So what where you have kept beat number one, so beat number one is kept at this position. So this position is considered as 40th beat. So 40th beat has to be taken over here. Are you getting? So this is nothing but initial permutation. This is nothing but final permutation. Okay, now this is one of the example that what is initial permutation box and what is the output of initial hexadecimal. Some numbers are given to you. Now this number 000080000, this is that, and then what you are doing is only the beat number 25th and beat number 64 are one. So this hexadecimal means what? A single character that will be considered as, so you are converting hexadecimal into binary first. So whenever you are converting hexadecimal to binary, this becomes 64 bit because 4 will 16, 16, 16, 16. So this becomes 64 bit. It is in hexadecimal form. So whenever you are in hexadecimal form at that time, you have to concentrate on what type of input and what type of outputs are there. So here again, I'm telling you that what is that? So first of all, convert the input plain text into binary beat. So binary beats are considered in case of all this. So beat number one, beat number two, where you are placing. So this is important. So which is this beat? So these are 16 beat. Then this becomes 24 beat, 32 beat. So likewise, 16 beat, 20 beat, 24th beat. 24th beat after that, this becomes 8. 8 means what? 1, 0, 0, 0. So this 25th becomes 1. 25th beat becomes 1. So 25th beat, you have to concentrate here. The 25th beat becomes 1. Other beats are 0. Likewise 2. 2 means what? Here the last beat is 60, third beat, 64th beat, isn't it? So beat 64 are 1 and other beats are 0, 0, 0. So in the final permutation, beat number 24 will become 64th beat. So 64th beat, so here it should be 63rd beat. 25th beat and 63rd beat are 1 and other beats are 0. In the final permutation, beat number 25th, where we are placing beat number 25th. So beat number 25th, here you can see over here that beat number 25th, where you have to place beat number 25th. So see this, where beat number 25th has to be placed. So beat number 25th is placed over here. Are you getting this? So likewise, so here beat number 25th is taken over here. So this is nothing but initial permutation where all the positions are changed. So here beat number 25th becomes 64th beat, and beat number 63rd, that becomes 15. Are you getting this? So 25th beat, what is 25th beat placed over here? So here in this case, 25th beat has to be placed where? So that has to be considered. Okay, and 64th beat. So 64th beat where you are placing over this. So 64th beat has to be placed at this, 63rd beat has to be placed at this position. So this position becomes what? So this position becomes 15th. So this 15th beat has to be placed over here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 8, 16. Likewise, all the beats are to be considered, and here the example is given where you have to place which beat. Are you getting? Likewise, all the beats are jumbled, and what you are getting is from the initial permutation, again you can get the final, from the final permutation, you can get the initial plain text beat. Now that was very simple, that you are having internal placement or transposition of all the beats, and what you are getting is their P boxes, and now exactly within all these rounds what are happening. So what is happening in all these rounds, that is again most important part, that what internally happens on in all these rounds. So what internally happens on in all these rounds. So see this properly, that what you people are doing or what is happening within these rounds. So as we have seen that each and every round, 16 rounds are there, and each and every round takes 64 plain text bits. So the first thing what we people have to do, or what the cipher says is 32 bit, 32 bit. As in case of Eastern cipher, the same criteria is used. What you are having is 32 bit, leftmost 32 bit, rightmost 32 bit, and then this leftmost 32 bit is given for XORing. The same criteria what we have seen in previous lecture for Feastal cipher, leftmost 32 bit are directly given, and rightmost 32 bit are using one round off function. Now this is very important round off function, that what is internally happen. So each round of DES is using Feastal cipher, is using the Feastal cipher structure. It is similar to Feastal cipher structure. So directly before giving it to XORing, the round off function, F function, which is nothing but round off function, what it does, a single round of DES. This is a single round of DES. What exactly is happening within this? Within this. So this is nothing but round off function. So the function, what it does, the function, what it does, that it is taking input, which is the rightmost 32 bit. It is taking input, which is the rightmost 32 bit. Now this 32 bits are expanded, and this is considered as expansion P box. So 32 bit is expanded, and this expansion is considered as expansion P box. So this expansion P box is converting 32 bit into 48 bits. So now see this, that whole thing analyzed properly. A single round of function does what? 32-bit rightmost is converted by Xbox expansion P box into 48 bits. 48 bits, as I told you, that from the 56-bit plain text key bit, you are converting that thing into sub keys of 48 bits. So key 1 is of 48 bits. It is taken for XORing with expansion P box output 48 bits. So whenever you are doing XORing means what? Say you need both the inputs which are same. You need both the inputs which are 0 and 0, you will get a 0. But if both are not same, if both are not same, then you will get answer as 1. That was XORing function. So 48-bit input and 48-bit input from the key, they are XORed. So XORing, again you are getting 48-bit. After that you are having S boxes. So S boxes are nothing but substitution boxes. So what the substitution boxes does? So how many substitution boxes are there? There are 8 substitution boxes. Input to substitution boxes as boxes, which are 8 substitution boxes, is 48 bit, and output is again 32 bit. So again, what is the purpose of as box? It is converting 48 bit into 32 bit. So you want the relationship between the plain text and that of cipher text should be as complex as possible. So because of that, internally many times substitution, many times permutation is performed in case of DES algorithm. So see this, there are 8 S boxes which are dedicated for converting 48 bit into 32 bit, And then you are having straight P box. Straight P box, again it is P box, which is simply transposition all this beats of 32 beat, and then again the output is again 32 beat. Now see this, the first thing within the round of function is expansion. Expansion P box. What is the purpose of expansion P box? It is converting 32 bit into 48 bit. So how this conversion is done? So here you can see that how the conversion is done. So see this, that 32 bit can be divided into 844 bit blocks. So you are having 8, 1, 2, 3, 4, 5, 6, 7, 8. 844 bit blocks. From 4 bit, I want to convert that thing into 6, because 6, 8 blocks, 8 blocks of size 6, that will give me 48 beats. So from 4 beats, I want to convert that thing into 6 beats. So how the conversion is done? So this 4 beats are taken as 4 beats, middle 4 beats of my 6 beat conversion. So from this, I'm having 6 beat from which the first and the last one. How to get that, I'll tell you, but middle 4 beats, beat number 2, 3, 4, 5 are directly adapted from the input. So whatever 1, 1, 1, 0, if this is the input, then second beat is 1, third beat is 1, fourth beat is 1, fifth beat is 0. But which is the beat number 1 and which is the beat number 6th? So 1 is nothing but previous block. So previous block last beat is considered as first bit of my this block, first block. So first block first bit is nothing but last block last beat. First block first beat is nothing but last block last beat, and the last beat of my first block is nothing but first beat of next beat, next block. Block number 2, whatever block number 2 first bit is there, that is considered as last beat of my first block. So last bit of my first block has to be considered over here. So you can see over here from the diagram, it is very clear that how you are converting 32 bit into 48 bit using expansion permutation. So in the expansion permutation, what we are doing, that from 4 you want to convert that thing into 6. So first is nothing but previous block last bit, last is nothing but next block first beat. Keep this thing in mind, only these principles are used in case of expansion permutation, converting 30 bit to beat into 48. So you are converting 4 bit to 6. Likewise, how many times you have to do the same thing? 8 times. So 8 into 6. So 8 into 6, what you will get? 48 bit. So 4 into 8, that is 32 bit. 6 into 8, that will give you 48 beats. So as I told you that you are having the first thing in a single round of S box, which is nothing but expansion P box. So expansion P box that you are getting by expanding the permutation box, converting 32 to 48. Now this 48 beats are XORed. So after XORing with the subkey 48 beats, whatever 48 beats you are getting, that is given to the S box. Now what is there in S box? So S box are nothing but substitution boxes. So you can see over here that permutation box, beat number 1, 2, 3, 4, they are as it is, but the first one is nothing but 32 beat. 32 beat means the last beat of my input. 32 bit input is there, first bit, second bit, third bit, likewise 30. Second bit is considered as first bit, and after 4 you are taking beat number 5. So next block, first bit, which is beat number 5, is taken as last bit of my previous block. Likewise, this is fourth beat taken from here, this is eighth beat taken from here, 12th beat taken from here. Next block beats are to be taken. XORing. Even XORing is very easy. That you have to 32 bit to 32 bit XORing is considered, and then whatever you are getting, that is nothing but the result. Now, most important part of your DS algorithm is S box. S box is nothing but substitution box. There are totally 8 S boxes in case of DES, and all these 8 S boxes are taking a 6 bit input. That 6 bit input is converted into 4 bit output. So in case of expansion P box, we have seen that 32 to 648 bit expansion is there. In case of S boxes, it is converting, it is the reverse. It is converting 48-bit input into 32-bit output. So all these S boxes are converting 6 to 8 mapping. How the 6 to 8? 6-bit input to 4-bit output. That is mapping which are done by S boxes, substitution boxes. Now see this, that exactly the algorithm is working like this in case of S box. Bit number 1, 2, 3, 4, 5, 6. 6-bit input is there. And from this 6-bit input, you want to get 4 bits output. So bit number 1 and bit number 6, they are these 2 bits. How many combinations are possible using 2 bits? So using 2 bits, you can have 4 combinations: 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 1. So because of that, there are 4 rows in S boxes. So S boxes are nothing but you are having a matrix, and this matrix is 4 cross 16. 4 by 16 matrix is nothing but size or dimension of a single S box. A single S box is consisting of a single S box is consisting of a single S box is consisting of 4 cross 16 dimension. The dimension of a single S box is 4 cross 16. You can see over here 0, 1, 2, 3. From the first and the last bit, you are getting beats. You are getting a value from 4. It is nothing but row number of my S box, and you are getting a value which are middle second to fifth beat. So middle second to fifth beat, which are 4 beats, they are giving me using 4 beats. How many values you can get? Maximum values you can get 16. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. Likewise, all the combinations will give you a one value from 0 to 15. All the values are 1, 1, 1, 1. It will give you 15. So because of that, what I'm getting over here is this are nothing but 15 columns, values of 15 columns. From 2 to 5, it is giving you 15 column values, and first and last bit combination, it is giving you 4 row beats. So from the 4 row beats, what I'm getting is row number, and middle 4 bits, what I'm getting is column number. So this is a table of size 4 rows, 16 column. So whenever you are getting any input which is of 6 bits, you have to see the row number, you have to see the column number, and then you will get a value within this table. So this is the table entry, and this table will always have a value lying between 0 to 32, because from 4 bits 0 to 16, from 4 bit how much value you can get? 32 bit, you want to get 32 bit. So from 4 bit value, how much value you can get? 15. So values within S boxes are 0 to 15 only. So you can see over here that this is one S box. S box 1. What are the values in S box 1? So 1, 2, 3, 4. Row number 1, row number 2, 3, 4. The values are using combination of 2 beats. First and last, you are getting what? 0, 1, 2, 3. So this is my first row, and the values, you can see over the values. Value 15 is there, 11 is there, 8 is there, 3 is there. You won't get any value which is greater than 15, because what is the ultimate goal of S box? Goal of S box is taking 6-bit input and it is giving you 4-bit output. So 4-bit output is nothing but value which is specified over here. From the first and last bit of 6 bit, you are getting what? The row number. From second to fifth, what you are getting is column number. And the combination of this row and column is giving you a value. Say this value is nothing but output of my S box, and this value is always of 4 bit. So if it is 10, what is the value? So it is 1010. 10 value signifies if my row number is 1 and column number is 7, the value is 10. So this is nothing but output of my S box 1. So just for your example, because DS you have to implement in your lab turn. In your laboratory, you have to implement DS. So understand DS properly, that exactly how DS is working. So now see this, that if my input to S box 1 is 100010, My input to S box 1 is 100. So it is 6-bit input. So first thing what we have to do is take beat number 1 and beat number 6 combination, which is 1 1. It is giving me what row number? It is giving me row number 3. Likewise 0001. This is giving me column number 1. It is giving me value 1. It is giving me 3. So here you have to see that number 3 row and column number 1 intersection, you are getting 12 as the answer. So 12 as the answer. What is the binary of 12? Binary of 12 is 1100. Are you getting? So because of that, if input is 10011, then the output will be 1100. Why 1100? Because the row number and column number intersection is giving you a value, and that value you have to convert the thing into binary. Whatever output you are getting, that is your answer. So one question I want to ask you, just if you are getting what is S box, just tell me that if my input is 11111, all these 6 beats are all 11111. What should be the output of my S box 1? Likewise, such 8 S boxes are there. You are having this type of 8 S boxes. Are you getting the question that if input 6 beats all are 11111, what should be the output of my S box 1? So you are taking the first bit and the last bit, so it is 1 1. So 1 1 will give you what? Row number 3, and again 1 1 1 1 1. So middle second to fifth bit is giving me 15 as the answer. So intersection of 3, row number 3 and column number 15, you are getting answer as 13. Are you getting this? So 13, the binary of 13 is nothing but 1 1 0 1. So 1 1 0 1 is nothing but your ultimate answer. So are you getting this? That how to look at the S boxes? Likewise, such type of, how many such type of S boxes are available? So you are having 1, 2, 3, 4, 5, 6, 7, 8. 8 S boxes taking 6-bit input, giving you 4-bit output. So are you there with me that what is the question which is given to you? Likewise, again I'm giving you the same type of question. 101010. This is the input to S box 1. What should the output? Write in your chat box 101010. Again, I'm repeating the question 101010. This is the input given to the S box number 1. What should be the output of my S box? S box is converting 6-bit to 4-bit. The output is a 4-bit. What is the value of this 4-bit? I want to get this value. Give me the answer. You can write in the chat box. Again, I'm showing you the chat box. Again, I'm showing you the S box. 101010. This is input to the S box. 101010. This is the input to the S box. What I'm finding is corresponding output of my S box. So 101010. Row number. What should be the row number of my S box? One is writing 04140. 04140. What is this? 04140. Okay. So Ashutosh has given the answer. So it is 101010. So 1010 is giving you row number 2. And middle you are having 0101. So 0101 is 3. So you are having 3. So it is intersection is 8. So the answer is 1000. So what answer you are writing? So it is 6. Ashutosh has written 6. I'm not getting why it is written 0 for this. So the ma'am, the answer, okay, 01 it is 5. Yes. So it is 5. So 0101 it is 5. So column number 5 and row number 2. Column number 5 and row number 2. So column number 5 and row number 2. When we are getting column number this and row number 2, the answer is 6. So for that you are getting 0, 1, 1, 0 as the answer. So Ashutosh has written proper answer, but all of you just concentrate properly, because from exam point of view, one 7 marks question or nearly 15 marks questions are to be asked from DES. And again, I'm telling you that all these DES, AES are interconnected, triple DES, they are of the same type. So I think that here I should stop and I'll give you the MCQ question for writing. And this is the last attempt. Those students who are getting the answers properly, I won't repeat the same questions again.